Hello PLP Geometry. Welcome to the fifth video in Unit 1. Unit 1 again is Intro to Geometry. Our fifth video is titled Congruence, Bisectors with Angles Involved. Okay. So again, Unit 1 here, Intro to Geometry. Intro to Geometry. And our fifth video, so this is number 5, again is going to cover congruence and more about bisectors. But this time we're going to involve what's called an angle bisector. So we're going to focus on angles. Okay, so very similar to the last video. So we're going to start with what a congruent or a pair of congruent angles are. So we have congruent angles. And congruent angles are angles that have the same measure, or angles with the same measure. Okay, so how's this going to look in a picture, right? Well, first I need two angles, so I'm going to draw two acute angles, all right? So my first one is going to be here. The vertex is going to be U. And I'm going to draw a ray UV and a ray UT. Sorry, T. Sorry about that. Ray UT. And then I'll draw another angle over here. Let's give the vertex a Y. Let's draw a ray YX going up this way. And we'll draw a ray YZ going that way. So again, I have two acute angles. So what you're going to look for in terms of congruent angles is either they have the same measure written, or they have what are called arc marks, right? Just like segments have tick marks, congruent angles are going to have arc marks. So these arc marks will look like little arcs like this inside the angle. So one arc mark, that means those two angles are congruent. If there are two arc marks and two arc marks, that means those two angles are congruent, right? So they have the same number of arc marks. So what this picture is telling me is that angle TUV is congruent to angle XYZ. And if those two angles are congruent, then I know that the measure of angle TUV is equal to the measure of angle XYZ. Congruent angles. Again, very important. We will use congruent angles a lot this year. Okay, and then lastly, an angle bisector. So what is an angle bisector? Angle bisector. So again, you have this word bisector. Remember that bisector means splits into two equal or two congruent parts. So if we have an angle bisector, what it's going to be is it's typically a ray. So it's a ray that divides an angle into two. I'm going to use that congruent symbol again. You can write the word congruence into two congruent. And then even for angles, typically I'll write the word angles for you. Angles. But typically what I use instead of the word angles is I use an angle symbol with an apostrophe S. That's my symbol for angles. So again, I like to use shorthand because it makes writing notes faster. They are your notes though. You do what you got to do. So I'm going to start with the angle A. All right, so that means the vertex is A. And I'm going to draw an AC going up this way, so ray AC and a ray AB going down this way. So again, right now, I could call that angle A, I could call it angle BAC, I could call it angle CAB. But once I draw this ray AD going kind of right through the middle of that angle, so again, if you imagine that angle, that arc going right through the middle of the arc, and again, I kind of cheated by doing it sideways, I'm going to put a D on this. What this ray has done is it has split the larger angle into two smaller angles. Now, once I tell you that it's an angle bisector, or I put these arc marks, right? Now you know that those two angles are congruent. Now you know that ray AD is bisecting angle CAB. No longer can I call any angle in that picture just angle A, because there's three angles at that vertex, the two small ones and the bigger one. So to describe this picture, I would say that ray AD bisects angle CAB. So because of that, I now know that angle CAD, that top angle, is going to be congruent to angle DAB, that bottom angle. And again, I want to emphasize we have to use three letters when naming because of the multiple angles at vertex A. And again, just because, or like we did in the last last slide, if the two angles are congruent, then their measures are equal. So the measure of angle CAD is equal to the measure of angle DAB. A couple of things to keep in mind with a bisector. So again, in this picture, each of the smaller angles is equal to half of the bigger angle. So we know that the measure of angle CAD, that top angle, is half the measure of angle CAB, the entire angle. And we also know that the measure of the lower angle DAB is equal to half of the large angle CAB. Notice those little M stand for measure. Perfect. Great. Okay, video 5 is done covering congruent angles and bisectors. Thanks for watching.